Hi students. Chapter 5, the coordinate geometry, introductions. The coordinate geometry, also called as an analytical geometry, in the branch of the mathematics, in which occurs in a plane or represents by as an algebraic equations. For example, the equation x square plus y square equal to 1 is describes a circle of a unit radius in a plane. The first degree of equations with the two variables ax plus by plus c equal to 0. Here an x and y are the two variables to represent as a straight line in a plane. So overall, the coordinate geometry is a tool to understand the concept of visually and created the new branches of mathematics in the modern times. Now let us to learn about the learning outcomes. To find the area of a triangle formed by the three given points. The second one, to find the area of a quadrilateral formed by the four given points. The next one, to find the slope of a straight line. The next one, to determine the equation of a straight line in a various forms. To find the equation of a line parallel to the line ax plus by plus c equal to 0. Next one, to find the equation of a line perpendicular to the line ax plus by plus c equal to 0. All these concepts form basis of a coordinate geometry. Let us to now recall some of the basics formulae. The distance between the 2 points. The distance between the 2 points a x1 y1 b x2 y2. This is a 2 points a and b. So absolute value of a AB equal to D. Distance between the 2 points equal to square root of x2 minus x1 whole square plus y2 minus y1 the whole square. You may see this is a this is a B. We want to find the distance between these 2 points. So how to find square root of x2 minus x1 plus y2 minus y1. Next one, a midpoint of the line segment. The midpoint of M of the line segment joining A x1 y1 and B x2 y2 is x1 plus x2 by 2 comma y1 plus y2 by 2. Means here this is a point A, this is a point B. In between these two, one midpoint to be the, how to find it? x1 plus x2 by these 2 points by 2 and y2 and y1 whatever. So y1 plus y2 by 2. The next one is a section formula. The section formula come across with as an internal division and external division. Now we are seeing the internal division. Let x a equal to x1 y1 and b equal to x2 y2 is in the two distinct points such that a point p xy divides a line AB internally in the ratio m is to n. Here see, this is a point, this is a B point. So point P, that means x and y, divides internally. How it is to be dividing? M is to n ratio. Okay, well, this is a x and this is a y. Then the coordinate of the P are given by that P is coordinating how it's dividing m into x2 plus n into x1 by m plus n and m into y2 plus n y1 by m plus n. Next one is the external division. Let A equal to x1 y1 and B equal to x2 y2 be the two distinct points such that the points P xy divides a AB in the externally in the ratio m is to n. Here see that A and B, apart from that AB, it has an one point that is to be called as a P. Externally the P equal to x and y. That is why it's called as an external division. So the coordinates of the P are given by m into x2 minus n x1 because it is externally. Just you please remember that is a m x2 minus n x1 by m minus n. M into y2 minus n y1 by m minus n. Externally means you put as a minus sign, internally means you put a plus sign. That's all, the simple. Internally means the point P in between the A and B. If it is externally means the P is apart from that B. The next one is a centroid of the triangle. The coordinates of the centroid G of the triangle with the vertices A x1 y1, B x2 y2 and C x3 y3. Here see, this is a point A, this is a point B, this is a point C. To make as an on triangle, so opposite to that in a AC, what is it to be there? Here B is a vertex to be there. Here this is a midpoint of that AC. We connect together to make a line. Like that in BC, which is a midpoint, this is a midpoint. So you connect through that with the vertex A. Like that AB is a line segment, you connect to the vertex AC. So in a midpoint. So all these midpoints is joined together to form a one line, one point. That point is called as a G. The coordinates of the centroid G of a triangle with the vertices A, B, C. This A, B, C. It's joined where it is all its coordinate G. So x1 plus x2 plus x3 by 3. Because it has as a 3 points. So 3. So y1 plus y2 plus y3 by 3. Have you got it? So like that is the centroid of the triangle. The next one is the area of the triangle. See, this is a x-axis, this is a y-axis. So x-axis and y-axis where it meets, it's in the 0. We will cut together in the perpendicularity. So it has as an one plane that A, B, C. It has as an 3 points. A has a x1, y1. This is a x2, y2. This is a x3, y3. So we enclosed all those points A, B, C. So A, B, C. We found in between this place, it is called as an area. See, in between the enclosed of ABC is called as an area. The area of a triangle ABC is absolute value of a expression. The area is equal to 1 by 2 into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 square units. You don't forget this word square units because we are going to do what? This is an area. So finally you mention the square units. See how to remember the easy for this formula. See 1 by 2 here you put as an externally x1, here x2, here x3. Okay. Internally in between the brackets you always to represent the y values. See here x1, so you put y2 minus y3. Where you ends y3, it starts in again in bracket y3 minus y1. Where it ends y1, you again start y1 minus y3. So it is easy for to remember. Okay. This is another form also to be there, that is a cross multiplication method. The area of a triangle is 1 by 2. You put like this x1 y1 x2 y2 x3 y3 x1 again you put as an where you start x1 y1 again you put as at x1 y1. So 1 you put x1 y2 x2 y3 y3 x1 like that you make an arrow. Another arrow y1 to x2 y2 to x3 y2 x1 like that you put another arrow. How to form a formula? The area equal to 1 by 2 x1 minus y2 x1 minus y2 here, isn't it? Plus x2 minus y3 plus x3 minus y1. Totally you put 1 minus, then you go for the next one y1 into x2 or x2 into y1 plus x3 into y1 or y2 into x3. Here y3 into x1 or x1 into y3. Put square units. Don't forget this one. Collinearity of the 3 points. 3 points A equal to x1 y1, B equal to x2 y2 and C equal to x3 y3. So will be the collinear of the area of the triangle ABC equal to 0. When the triangle equal to collinearity, it became a 0. So how it is a x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 equal to y1 minus y2 is equal to 0. The next one, the area of the quadrilateral. So here we saw that on diagram, this is a x-axis, this is a y-axis, where it meets 0, 0. It is an origin point. We have as an one plane to be A, B, C, D. It has as a 4 points. When it has as a 4 points, it has as a quadrilateral. So how to find the quadrilateral area? So divides a quadrilateral into two halves. So here this is a B vertex to joined as an opposite D. When you draw the line, it became a two triangles. That's the way the area of the quadrilateral ABCD is equal to the area of the triangle ABD. See, ABD plus area of the triangle BCD. BCD. So the area equal to 1 by 2 into x1 minus x2 into y2 minus y4 minus x2 minus x4 and y1 minus y3, you close the whole bracket into square units because we are mentioning area. This is a normal form of that area to find the area of the quadrilateral. We have the another one simple method for the cross multiplication method. So the another form area of the quadrilateral ABCD is 1 by 2. You put x1 y1, x2 y3, sorry y2, x3 y3, x4 y4, then again x1 y1. You put as a modulus or whatever. Okay. Then the area equal to 1 by 2 x1 y2 plus x2 y3 plus x3 y4 plus x4 y1. Then whole thing minus, when now it is going, the arrow mark it going upwards. So it's a next section comes. So x2 y1 or y1 x2, whatever the thing. So y2 x3 we put is in the x3 y2 according to the alphabetical order. So here it is a x4 y3. Here x1 y4. It is an alphabetical order. So we will mention as a square units. So this is another form of the area of the quadrilateral ABCD. Okay.